Good question. Not 2%. 20%. Oh.
You're closest to me. The microphone is recording your conversation. Alright, so let's move on. So let's review the 4 different laws, gas laws. So let's start with the ideal gas law that you learned from chemistry. Let's review it again. Alright, so let's say I have a container, or let's say a cylinder with a piston, okay, and then you place gas inside. So this is your piston, and here's your chamber. Okay. So chamber, so there are some terms that we'll be using here. So let's say I'll put an ideal gas inside. Okay, give me an example of an ideal gas. Anyone knows a gas that we always use? What gas? Nitrogen, and then oxygen. What is that? Guys, give me an example. What is it? Let's say we put air inside. And then when you place the lid or the piston, is it an open system or a closed system? So it's a closed system. So it means that the number of molecules inside will not be affected. Okay? So in our lesson in chemistry, there are 3 properties when we have the gas. Okay, first of all, what do you know about gas when you put them in a space? Of course, we have what? Pressure. Second information that we know about gases is that it does occupy space, and that's volume. And then last but not least, when we feel something's hot, then you have what? Temperature. So PV and T. So we have pressure, volume, and temperature. At the same time, what's inside this ideal gas, okay, in chemistry, we call the number of, so we use N. What does N represent in chemistry? So let's write it down, chemistry. So when we talk about chemistry, N represents what? Really, guys? What's N? What's N? Number of moles. Okay. Alright, number of moles, which is N.
And like 8 moles or something? Like this certain amount of moles?
Yep.
So that you can be complete, and like that's kind of how fluid works as well.
So number of moles, okay, molecules.
Good,
And therefore, the number of moles. And if it's an ideal gas, the ideal gas would have what we call R, which is the gas constant. Okay. So R meaning this is your gas constant. So depending on what kind of gas you have gas constant, and in chemistry that gas constant is measured in terms of joules per mole Kelvin. So this will be the unit for R. Okay. So R. So that's the idea there. That's chemistry class. Now let's move on with physics or engineering classes. So for engineering classes or physics, we don't use number of moles because we won't be able to count the number of moles, but instead you can measure the amount of matter. Okay, when you measure the amount of matter, what do you change your N? You change it to what? So if you count the number of moles, you multiply it by the atomic mass number, what do you have? The number of molecules multiplied by the atomic mass number. What? You have the mass. So you change your N to M. Okay. So in physics, we use M instead of N, which is mass, because both of them just say the amount. What is the unit of mass? So it's usually kilogram. Sometimes we use what? Grams, especially for density. But for this class, for this topic, we use kilograms. Okay, R is still the same thing, gas constant. Gas constant. But now our unit will not be joules per mole, but joules per kilogram Kelvin. So per unit of temperature and mass. Okay, according to the ideal gas law that is established by Mr. Clapeyron. Okay, so here's the name of this scientist. who came up with this information. His last name is, I don't want to misspell his name, so let me just focus on writing it down. Clapeyron. Okay. So this is the name of this scientist. However, in the next couple of pages, we will be talking about this same law, but it will be changed into something else using laws from Mr. Boyle's, Charles, and then we have the Avogadro's law, but we're not going to go over Avogadro's law, that's chemistry, and then you have Gay-Lussac's Gay-Lussac law. Okay, so we have Gay-Lussac law. Now, let's move on. So what is this equation? Okay, so in chemistry, you've seen this before, and that is PV equals NR times T. Okay guys, NRT. However, we're not going to use the number of molecules. We're not going to go on the molecular level, but instead, we will measure the amount using this. PV is MRT. Technically, this is the work done by the molecules. So if you remember in first law of thermodynamics, first law, we have the change in internal energy is equivalent to Q plus W. This W is the same as P times V. So this one right here, P times V. So if you multiply pressure and volume, that is basically your work. Okay. So this is the equation that we're going to go over today and try to apply it in our lesson. Okay. So what are we going to do next? What are we going to do next? Okay. What are we going to do next? Are you done copying? Okay, we're done copying? Alright, so if we're done copying, we can move on to the next page. Let's go over example number 1. Okay, so let's go over example number 1. Are you done copying or not yet? You know what? I forgot something. Let's go write it down. Okay, I forgot to mention stuff. Okay, so what are some of the information that we have here? Where? What is your PV? What is P? P stands for? Pressure. So what are the units of pressure that you might encounter here? You might encounter PA, which is what? What is PA? That's Pascal. We can encounter kilopascals, and sometimes you will see atmosphere. Say kilopascals or atmosphere. So pascals, this is the unit that we're going to use. So what is 1 atmosphere? Equivalent to how many Pascal is it? 101,325 pascals. So it's something that you must memorize that value. Second one is your volume. Okay, volume V, and most of the time, or the accurate unit that we're supposed to use is cubic meter. Cubic meter, but sometimes it's exposed in terms of liters. What's another unit? Cubic centimeters. You have ml. So those are other units that we need. Okay, so 1 cubic meter is equivalent to how many liters? 1,000 liters. Okay, so that's 1,000 liters. So 1,000 liters to 1 cubic meter. I'm not so sure if family size is still available in terms of soda. Okay, so T is what? What is T? What kind of temperature? It's uppercase. Absolute temperature. Absolute temperature. And that is in terms of Kelvin. So we have what? How do you solve for T? T is degrees Celsius plus 273. So those are some of the information that you must remember. Okay. If you don't remember it, it's open notes, then you can use your notes. Okay. Now, special value of R. Value of R. So value of R. R of air. Okay, R of air. So just remember that R of air is 287 joules per kilogram Kelvin. That's just the beginning, okay? It's just a review. This is chemistry, so it's just the beginning. Alright, so ready? Done copying for this info? Okay, ready? So let's move to the next part. Okay, guys, let's move to the next part. Where do I have this one? Right. Okay, let's go to the example. Let's work on the example right here. Okay. So a sample of helium gas occupies 5 liters at 22 degrees Celsius and a gauge pressure of 200,000 pascals. What is the mass of the gas? Okay. What is the mass of the gas? Okay, so sample number 1. So let's write it down. So we have 5 liters, 5L. We have, what is 5L, guys? 5L is liters. So what is 5L? What information is that? Is that volume or mass? Liters. So this is your volume. So 5 liters. But we cannot use liters. Instead, we have to convert this into cubic meter. So cubic meter will be on the top, which is bigger. And there's 1,000 liters. So you divide 5,000 by 5 by 1,000. So therefore, your volume will be 0.005 cubic meter. So that's volume. The next information that we have is 22 degrees Celsius. So that's lowercase t, 22 degrees Celsius. So how do you change this into uppercase T? So that's 22 degrees C plus how much? 273 degrees, or 273. So this will give us an answer of 295 Kelvin. Okay, pascals. How many pascals do we have? So that's 200,000 pascals. Okay, 200,000 pascals. So what is pascals? Represents pressure. So it represents pressure. So therefore we have 200,000 pascals for pressure. What other information that we know? What's the value of R? So 2.08 times 10 to the third power. And the unit is joules per kilogram Kelvin. And what are we solving for? So we're solving for mass. So we don't know mass is. So the only equation that we know is simply PV equals mR times T. I want to solve for M to be by itself. So what should I do? Divide both sides by Rn T. So Rn T, RT cancels out on one side. So we can say that mass is simply equivalent to pressure times volume divided by Rn T. So what is your pressure? That is 200,000 pascals multiplied by 0.005 divided by, what is the value of R? 2.08 times 10 to the third power multiplied by 295 Kelvin. So what is the amount? So if you simplify this, you will have 0.0016. And what's the unit of mass? It is in terms of kilograms. So that is how you apply the ideal gas law. You've done this in chemistry class. Okay, you've done this in chemistry class. Let's apply. Here we go. Now, how about this, guys? Okay, so we put the gas. Okay, so we have gas inside with an ideal gas, and we have a movable piston. So let's say this piston can go in and can go out. Okay, can go in and out. So we have certain amount of molecules inside. Okay. So let's call this one condition number 1. And then we have the second one, which is the same one. Step 2, what I'm going to do is, let's say it's the same piston, same cylinder. What I'm going to do next is to compress it. Okay, we compress about this one. So this is point number 2. Okay. What do you notice about the molecules? The molecules will be, will they change the number of molecules? Stephanie, will it change? No? So if, let's say I have mass inside, mass number 1, what happened with mass number 2? Do the mass changes? Do you have matter going in and out of the system? No. It's not only that, you don't think so. It's not gonna move in or out, because what kind of system do we have? It's a closed system. So in this kind of scenario, every time that we talk about it, it's a closed system. So what do you know about M1 and M2? They're the same. So M1 and M2 are the same, so we can just call it mass. Now let's talk about the R inside, R1 and R2. If you compress, for example, if I lose weight, will I still be the same person? Yeah, so you don't change. Instead, you just change your appearance. So in our case, this is a compressed gas compared to the other one that is uncompressed gas. So meaning our R1 is still the same as R2. And we can just call it R. Now, this time, it's going to be different when we talk about pressure, isn't it? What do you know about pressure 1, volume number 1, and temperature number 1? Compared to pressure 2, volume of number 2, and temperature of number 2. The lady, which one do you think has a greater P1 or P? Anyone? So, anyone who would like to help her? Carmelo, what's your answer?
2.
So P1 compared to P2, which one is greater?
P2 has greater pressure.
Okay, so greater pressure because you compress it. Let's talk about volume. Which one is greater? So look, guys, this one has more space compared to this. So which one is a greater volume? So 1 will have a greater volume, so it's the other way around. In terms of temperature, what do you know about putting together a huge amount of matter into a small space? Which one? What will happen when you compress it? Or you build up heat. So therefore, the temperature will also increase. Oops, not equal sign, but T2 will be greater. Why did I put equal? So T1, T2. Okay. So if we're gonna analyze this, so P1, V1 equals what? M1, R1 times T1. Okay. So which one is the same? So the same one is M1 and R1 will just be the same as what? P1, V1 equals MR, T1. Okay, guys, I want to make sure that everything with the subscript 1 is on one side of the equation. So what's the best thing to do? You divide both sides by T1. So what do we have now? This one cancels out. So we have P1 V1 over T1 equals MR. So that will be for number 1. All right. So far, are you getting along with it? Catching up with it? Everything's clear? Somewhat? Alright, you just watch it again later. Alright, next. How about for the second part? P2, V2, or the product of volume and product number 2 is equivalent to M2, R2, T2. Same process. We know that those masses NR did not change, so we can say that P2 V2 equals MR times T2. So just divide both sides by T2 again. So therefore T2 will cancel out on one side, and we have P2 V2 over T2, which is equivalent to MR. So any volunteer, let's have Anna. What do you know about MR and MR? MR on the left side and MR on the right side. What do you know? Are they the same, Anna? If they're the same, then I can say what? MR on the left side is equal to MR on the right, isn't it?
So MR2 equals MR.
So if both of them are the same, then I can say that P1 V1 over T1 is the same as equal to
P2 V2
P2 V of 2 over T of 2. There you go. So this will be our first relationship of what we call gas law. Gas law, which is the ideal gas law. Okay, air of mass M. Okay, guys, what do you know about the mass? Mass of the air.
That's 5 liters.
You know what? Let's put it right here. So, for example, condition number 1. Condition 1, and then we have condition number 2 right here. Condition 1 and condition 2. You know what? That was my mistake. So let's compress. Let's compress it. So we are going to compress the gas inside. Okay. So how much gas do we have inside? Letter M. Letter M. Okay. And then the R, because we have the same gas. And what kind of gas do we have? It's air. So therefore R is 287 joules per kilogram Kelvin. Kilogram Kelvin. Now let's take a look at information on number 1. What is the original volume? What is the original volume? We have 2 liters. And then we have a temperature of 30 degrees. Okay guys, 30 degrees Celsius. So this will be V1. This one is T1, which is lowercase t. So what happens? We have to change this to 30 degrees C plus 273 all the time to come up with T1, which is, how much is 273 plus 30? That is, how much is that? 303? 303 Kelvin. And then the pressure is how many atmosphere? 1 atmosphere. And then we have to change it to Pascal. So how many Pascal is 1 Pascal? Is 1 atmosphere. 101,325 Pascals. So P1 is equivalent to 101,325 because atmosphere cancels out Pascals. Okay, here we go. So that's for the first condition. Second condition, how much do we have? So condition number 2 is going to be different. What is your volume? We don't know the volume, so we're trying to solve for V of 2. Now, for T1, how much is your T2? It was heated to a temperature of 100 degrees Celsius. So to change it to T2, That is 100 degrees C plus 273. So what is your T2? That is 373 Kelvin. And then last but not least, our second pressure, that will change into 5 atmosphere. So you're compressing it from 1 to 5. So that is 1 atmosphere multiplied by 101,325 pascals. So your atmosphere cancels out. So pressure number 2 is equivalent to 506,625 pascals using your calculator. So now you know your volume, you know your temperature, pressure. So we can definitely solve for. So let's use P1 V1 over T1. That is equivalent to P2 of V2 T of 2. So let's just plug in those values in order for us to solve it. What's the value of P1? 101,325. That's 325. So that is pascals multiplied by volume of 2 liters divided by a temperature of 1, that is 303 Kelvin, equivalent to, what is the second pressure? 506,625 pascals multiplied by volume over, what is our temperature? That is 373 Kelvin. Alright, what happened with our Kelvins, guys? Okay, so let's manipulate the equation. So let's multiply both sides by 373 and divide both sides by 506. So therefore we have, so that's 101,325 pascals multiplied by 2 liters multiplied by 373 Kelvin divided by 303 Kelvin times 506,625 pascals. Guys, what happened with Kelvin? Kelvin's canceled out, pascals and pascals canceled out, so our answer should be correct because that is in terms of liters. So simplify this using your calculator. You should have an answer that is equivalent to 0.42 liters. So that should be your answer here. 0.42 liters. Now, question is, how do you solve for letter M? It's your mass. Yeah, how do you solve for mass? For letter A. So for letter B, can you still see it? Can you see it, guys? Alright, can you see the answer? Alright, so let's solve for letter B. How do you solve for M? B. What's the equation? P1 V1 equals what? M R times T1. So all you have to do is solve for M by dividing both sides by mass. So like what we did on the first question, like this. Same process. So what is your M? P1 V1 over R T of 1. So if you plug in those values, you will definitely get the correct answer. 101,325 multiplied by 2 divided by 287 times 303. So your mass is somewhere at 0.002 kilograms. Okay, so that's the first part of our lesson. Since most